Meet Team TendonEase Tech, a group of engineering students from Georgia Tech. Our mission? To give power tools back to individuals who thought they could never use them again. Millions of Americans suffer from impaired hand function due to conditions like spinal cord injuries or arthritis. Many rely on TendonEase as grip, a passive grasp created by wrist extension. But try using a standard drill with just that grip. It's not only difficult, it's dangerous. That's why we created TendonEase, an adaptive electric drill designed specifically for one-handed use by individuals with impaired grip strength. The TendonEase drill addressed three core needs: one-handed usability, precision, and safety. Users activate the drill through a two-step system: a safety button and a knuckle/elbow activated power button. Speed control is handled through a sliding potentiometer that can be adjusted with a thumb, knuckle, or opposite hand. To help users stabilize the tool, we designed height-adjustable air springs supported legs that mimic a mini drill press. And for safety, our tearaway straps automatically detach and cuts power if dangerous torque is detected. To evaluate proof of feasibility, we used user-centered testing and engineering metrics. We tested electrical performance, RPM exceeding 13,000. Thermal levels staying well under 44 Celsius, and sound at 1 foot was under 85 decibels, meeting our goals for speed, safety, and comfort. Battery testing showed over 30 minutes of continuous runtime. We then conducted structural integrity tests. Pull-apart testing with an instrument machine showed our design withstood over 300 newtons, 50% more than our required 200 newton load. Drop testing from 1 meter in multiple orientations showed only minor damage in 7 out of 10 tests.
We performed finite element analysis (FEA) on key structural components of the drill to predict stress behavior under real-world loading. Here you can see the drill shell with deformation beginning at 841.2 pascals, maxing out at 8,412 pascals. Here you can see the gearbox where the deformation is from 7.88 times 10 to the 4th pascals and up to 8.76 times 10 to the 6th pascals. You can here see the last component, which is the shaft, with the deformation at 3.59 times 10 to the 5th pascals and up to 1.44 times 10 to the 6th pascals. And overall, when we look at these FEA analysis, we know that the gearbox can sustain a good amount of stress, and so can the shaft, confirming robust internal mechanics.
We also evaluated our tearaway strap safety system. With an average detachment force of 6.24 newtons, it's well within the pull strength of our user population. It successfully held the weight of the drill during 6 vertical load trials. What makes TendonEase innovative is not just the features, but the thought behind them. We reimagined what a drill could be for someone who can't grip, twist, or stabilize a traditional tool. Our team developed a 3-stage planetary gear system for high torque with low input effort, a redesigned shell, and grip optimized with a passive tenodesis grasp. A control layout that allows the drill to rest safely on one side while the bit and battery are changed. A fully modular support strap that prioritizes user safety without sacrificing control. Features enhancements include customizable support feet, bumpers for easier battery and bit exchange, and improved internal impact protection. We aim to take this from a prototype to a market-ready product because everyone deserves a tool to build and create, no matter their physical limitations. TendonEase isn't just a drill, it's freedom, empowerment, and independence for users who've been left out of the conversation. We're TendonEase Tech, and this is how we're helping users regain control. One drill at a time.